Okay. Okay, so we are doing a problem with Kramer's rule. So even if this was not your problem, pay attention, because you're going to have to do a problem with Kramer's rule. So Kramer's rule, remember, is the method of using just determinants. Everything is determinant. So we start with the determinant 3, 2, 8, 5, correct? And we evaluate that. Pay attention, because some of you are doing this backwards. The determinant starts here with the first number, so 15 minus 16. So the determinant is -1. That means that my answer, and again, some of you are not writing as ordered pairs. Your answer is an X and a Y, and both X and Y are something over -1. To find the something for X, for this one, we're going to cut these out, and these are the X numbers right here, these are the Y numbers. Take the 10 and the -7 and paste them here. So 10, -7, and then 2, 5. Some of you are moving things around. Nothing gets moved. We cut and paste. So 10, -7, 2, 5. And then for Y, we'll do the same thing, only we'll cut that out and paste it here. So we have 3, 8, 10, -7. So we have 50 minus -14, that's 64. And then we have -21 minus 80, that's -101. And then we simplify, so my answer would be -64, +101. All right, who else?
Can you use number 7 on that? Same page. Number 7.
That was number 7.
That was over 8.
Oh, that was 8? Oh, 7. I gotta see. Did you do the 2 hard quiz?
Yeah.
Okay, so 3x. Alright, so 3x minus y squared equals 5. X plus 2y equals 4. And it says solve in a manner of your choice, but you really don't have much choice with this one because, well, I guess you do kind of. You could eliminate, but if you eliminate, you have to eliminate the x's. There wouldn't be anything else because these don't match. You're not using Kramer's rule because you got a squared in there and that changes the game. So, Jake, you want to substitute or eliminate? All right, if we substitute, then I would definitely recommend solving for x. So x is 4 minus 2y, and then plugging that in right here. So 3 times 4 minus 2y minus y squared equals 5. So 12 minus 6y minus y squared equals 5. I'm going to clean that up. Shove everything over there. So it's going to be y squared plus 6y minus 7, which is a quadratic equation that factors. If it didn't factor, I could always use my formula, or I could use my formula anyway, but it does factor. So, y plus 7 minus 1. If you FOIL that, Jake, this is what you get. Okay? So that means I have 2 answers. one of them has a y of -7. These are y values, so they go at the end of it. Those are y's, and a y of 1. So then I can come back over here, and if x is -7, or excuse me, y is -7, then it looks like x is going to be 18. And if y is 1, then it looks like x is going to be 2. Alright, Joe?
3 on the one with 1 heart. I just don't know what I did wrong.
Finding the determinant. So did you recopy your first 2 columns?
Yeah. Might have been the original.
So we got 0 and -10 and -12. So I got -22 for that.
Yeah.
And then I got 0 and -2 and 0 for that. So I got -2.
Yeah.
And then I subtract them.
Yeah.
So -22 minus -2 is,
I flipped it around. I did -2 minus -26.
no. It's these minus these.
Wait, so when you're doing the determinant, you always have to be all subtraction?
What did I did?
These are these.
Okay.
These are added. Okay.
Yeah, you're good. You're good though.
All right. I handed out a review packet yesterday. Get it out.
No, please.
Yep.
I don't think we got cool. Number questions?
Well, I don't know where you had. No one raised a hand, so I thought it was done. Well, one more quiz question. Which one?
Number 1,
On which quiz?
the heart, 1 heart.
1 heart. Number
Or
1.
number 2.
Number 2. Alright, so we're doing a number 2. We're doing a matrix multiplication. And what we are multiplying is -2, 3, -1, -5 times. So, first thing I do is make sure I can even do it. So this one is a 2 by 2, 2 rows, 2 columns. This one is a 2 by 3, 2 rows, 3 columns. So I can multiply, and my answer will be another 2 by 3. Because of this right here. So then I multiply row 1 times column 1 to get that number right there. So -2 and 1, -2 and 3 times 1 and 1. That gives me a 1 in that spot. And then row 1, column 2. So it's still -2, 3, but now it's -1 and 1. So that's going to be 5. And then -2 and 3 times 4 and 2. So that's going to be -2. And then I turn around and repeat, but use that row, so -1, -5. Times 1, 1 first. And then -1, 1. And then 4, 2. So that works out to be -6. All right, if you have more questions, we do have this thing called office hours.
I
Right?
get that.
Even extra packet,
Huh?
even extra packet.
Will you actually have to?
No, dear, I just didn't get one. I looked through everything, I actually did not
Well,
get
I don't know if I do, they're back there in that black bin.
These are loosely paper.
I have no idea what happened there. All right, here we go. Let's look on page 2. Page 2. I want to do some dedicated review on stuff that we did. What we did notes, and that's about it. I want to make sure that we have a good command of the problems on page 2. So, we're going to do, on page 2 of the review, and we're going to do either A or B. So it doesn't matter to you which one we do?
No,
We'll do A. So your job is to split this up into 2 smaller fractions.
factor the bottom.
First thing we do is factor the bottom, and that will be x minus 2, x minus 1.
And that cancels out.
And that means that my two fractions will be one of them over x minus 2 and one of them over x minus 1. And I need to figure out what the numerators are. I don't want to call them x or something, so I'm going to call them a and b, you can separate from the x's. All right, everybody good so far? Okay, so now we're going to get rid of the denominators, okay? We want to get rid of all the denominators. So we are going to multiply each fraction by x minus 2 and x minus 1. Now, you don't have to write this down, but for the benefit of the people who may need to see it, I'm going to write it down. You can do this in your head. I am writing it down. So what is happening is I am clearing my denominator, okay? I'm getting rid of everything. So here, the whole shebang cancels out. And all I have left is 4x minus 5. Here, that part cancels out. So the A is left with x minus 1. And then similarly, the B is left with x minus 2. No more denominators.
4 equals AX.
So I'm going to go ahead and distribute. And then this right here is the key, that is an equals. So the x's on the left have to match the x's on the right. So how many x's are on the left? 4. How many x's are on the right?
2.
No, A
B.
plus B. There's 2 terms with x's, but ax plus bx has to add up to 4x. So A and B have to make 4.
Plus A plus U.
And then
5.
the ones without x's, so the plain numbers, negative 5 has to be equal to negative A minus 2B. So if you are a boxed part, you equal, left equals right. If you are an unboxed part, left equals right. Everybody see it?
Yeah.
So now we've got a system of equations. And this one is set up beautifully for,
Elimination.
now, could we substitute? Sure. But look at it. Oh my goodness, it's set up.
Right here.
So negative 1 equals negative b. So b equals 1. So the number, the letter b, which is over x minus 1 in my problem, so 1 goes over x minus 1. And then, if b is 1, then it looks like A
Four.
has to
Three.
be 3. So 3 over S minus 2. And here are your partial fractions. All right? If you need more practice, there's another one there. I'm not going to do it now, but there's another one right there. All right, now I want to do the problem in the box. Find the area. Now you only have one class period to take this test. The problem in the box can be done many different ways, but most of them are going to take far too long. So we're going to do this the short way. Here's my triangle. Point A is 1, -2. Point B is 3, 4. And point C is -1, 1. Now, some of you are freaking out because, wait, those points don't look right. Kids, where I put them doesn't matter. If you're really uncomfortable with it, get out a piece of graph paper and go ahead and graph them, but that isn't important. What's important is that you look at how are we getting from A to B? How are we moving from A to B? Well, we're going from 1 to 3, which is +2. And we're going from -2 to 4, which is +6. Then figure out how are you going from A to C. All right, this is important. We're going from A to B and A to C. Okay, so A to C is -2. And -2 to 1 is 3. Does that look all right? Some of you missed this in homework because you didn't have this part right. So take your time, get those correct. Then make a determinant out of that. So that will be 6 minus -12. Which is 18. But remember, it's a triangle and you gotta have half. 1/2 base times height, 1/2 side side. Hero's formula, they all involve a half. So make sure you divide that 18 by 2 and your area is 9. If by chance, I mentioned this before and I mentioned it again, if by chance you do your determinant and it comes out to be -18, that's okay. Make it +18, divide by 2.
Negative, so just switch positive.
Yeah,
Because you can't
because,
make a very.
you know, and that will happen, so I did AB and AC in that order. Had I used the same set of numbers in this order, it would have come out negative. Ignore the negative. All right.
Can you have done B, C, and BA?
Yep. B, C, and BA, or CA and CA.
But you have to have that comment.
You have to have that common starting point. So you're like sitting at a vertex of the triangle and going out both ways from it. Got it?
I got it.
Okay. Next thing I want to do is on the back of that page, so the back of page 2, they're not numbered, but I want to do the one that's at the top. Solve using the inverse method by hand. Right? We'll do this and then we'll try and do one at a time. All right, so solve using the inverse method by hand. So we need 2 matrices. In a while, we'll do one of these on our calculator. But we're doing this by hand, but regardless, we need 2 matrices. We need a matrix of the coefficients. So this is 1, 2, 3, -1. And then we need a matrix of the other numbers, yeah, the equals numbers. Are you with me? Now we're gonna find the inverse of this. So we're gonna find A inverse. that is a two-step process. The first step is find the determinant. So the determinant would be -1 minus 6 or -7. Good?
Yeah.
And then we do that fancy tricky stuff. We take these two numbers and we flip them.
And the other two change the sign.
And these two change sign, yep. So these two, this is kind of an unfortunate combination here, but these two literally flip-flop. So -1, 1, flip-flop. And then these guys, if they're positive, they become negative. What? Yep, they change sign, literally change sign. Okay, and then we divide each of these by the -7. So your inverse is 1/7, 2/7, 3/7, -1/7. Remember that? To get my answer then to the question, I take my inverse matrix and multiply it times my B. So I am gonna multiply that times B.
How?
What do you mean how?
It's a 2 by 1 multiplied by 2 by 2.
Wait, what does this say? This says take A inverse times B. So A inverse is this guy, and that's gonna be multiplied by this guy. And that's a 2 by 2 times a 2 by 1, and that's perfectly okay. It's gonna give me another 2 by 1, which is gonna be my answer, X, Y. So here we go, this is easy. Row 1, 1/7, 2/7, times column 1, 8, 3. Now, you're always gonna have a common denominator, so if you wanna just forget the fraction for a minute, you can. You have 1 times 8, you have 2 times 3. That makes 14, and then divide it by 7, 2. Then you do row 2. Times 8, 3. And that's gonna be 24 minus 3, which is 21, divided by 7 is 3. So the answer to the problem is 2, 3. All right, that's called the inverse method. So earlier, we did a problem like that. We're using Kramer's rule, right? So those are separate. This is how we do the inverse method.
Can we, for an answer, can we write it as an ordered pair or as a matrix? Oh, it has to be by pair.
Okay, guys, are we done? Yes. All right, so go to lunch. I will see you back at 45, ready to review some more.
Wait, how did you get that?